All right, everybody. Welcome to episode 2 of season 2 of building a second brain app. And I can hear myself, so that's a good sign. And hopefully this time around we're actually using this microphone. But yeah, it looks like. All right, so once again, sorry, last time accidentally I misconfigured my setup, and instead of using this microphone here, everything was recorded through the MacBook, which is over here. And honestly, it was quite a surprise that it did record anything at all. In this entire series, last week's video will be very soft in comparison to the other ones. So today I want to continue where we stopped last time. And so if you didn't have the time to join last time we looked into using Genkit to compute embeddings for the full text of the articles that we store in our second brain app. So maybe a quick recap why that's important. So what we want to achieve in the long run with this second brain app is that the user can store all sorts of stuff in their database, and that might be blog posts they come across, or maybe even PDF files, or any other kind of resource really. And we want to make this discoverable, right? So if you imagine you're storing stuff into an application like that, it accumulates. And you want to be able to find that information again. So that is the first challenge. And the second challenge that we're facing is, or the second stretch goal, if you will, is that we want to be able to talk to our knowledge base. So, how amazing would it be if you store a lot of stuff about a topic that you're really interested in, something that you might want to learn, for example, into your knowledge base app, and then you can start talking to it and you can ask it questions. So in order to be able to do that, we need to teach our application to understand the user's question and then find the most relevant documents and articles that are stored in the database. And one way to do that is to use vector embeddings. So I explained last time what vector embeddings are, but a very brief recap. There are essentially arrays of floating point numbers. And those floating point numbers represent the many different qualities of a word, of a sentence, and even of an entire article or anything really. And by storing those embeddings in a database, we can then use the database to help us retrieve those the documents that are the closest to the embeddings that represent the user's query. So if you imagine that you've got all your documents in the database, you store all the embeddings in the database, and then the user asks a question, you compute the embedding of that query, you will hand it to the database, ask the database, hey, give me the documents that match this query the most. The database will take the embedding, search all the documents that are closest to the embedding, and give it back to you. And then you can either display those documents, and that is literally just semantic search, or you can take those documents and maybe take the one that's matching best and then put it into a prompt and send the prompt to the LLM. And part of the prompt is the user query, right? So if I, as the user, ask a question, hey, what do I need to know about asynchronous programming in Swift? and I've stored a bunch of articles. It finds the best article, let's say it's one by Matt Massicott, for example, takes this article, adds my question to the article and says, given this article here that Matt wrote, what do I need to know about asynchronous programming in Swift? And then the model will generate an answer based on this context alone. And the power of this approach is that you can really use an LLM that has a training cutoff date to reason about context and data that is not part of the training data of the model and might be after the training cutoff date. Or maybe it is from inside your enterprise, your company, right? And maybe the data that you want to ask about is not public, and you never want to make it public in the first place, right? So that means that you can't use one of the public models to reason about it unless you use this approach. Okay, so that is enough of a recap of what we did last time. While I'm getting my windows ready here, maybe you can say hello, and I don't know. Maybe you can tell me what is your favorite LLM, and you can say anything, so I won't be offended if it's not Gemini. And maybe what you like the most about it. So use the live chat. You can see it here. Nice. It's here. So anything you type in the live chat will be visible here. I'll keep that window up, and hopefully it'll stick around for the session so others can see your response. All right, so let's switch over to this window layout. Oh, look at that. It did lose the context. I'm sorry about that. Well, but I'm going to stay in this layout, so your chat messages should stick around there. So, welcome, Carter. Nice to have you back. Also, hello, Dean. Great to have you on. And if you haven't said hello, say hi. It's great to have you all. All right, so let me go into my window over here. And let's rearrange my other windows here, so I have my notes. Hello, what is going on? Okay, here we go. Cool. So maybe we can first go into the console to briefly have a look at what we did last time. And I just realized that we used the emulator last time. So let's do that. So I've got my project from last time here. And so for those who watched the how we built the front end in Swift UI, this time around, no Xcode, no Swift, everything is TypeScript and JavaScript this time around. I'm not a TypeScript expert myself, but you know, the tools that we can use, they will help us. So bear with me. So what we did last time was we implemented this update embeddings method here, and what it does is it registers as a Firestore trigger. So every time we write something to the database, this trigger will run. It will get the new document snapshot, and it will also get the previous state of the document. And then we're going to extract the full text from the document, and we're going to compute the embeddings of this document using text embedding Gecko, which is an embedding model, and then we're storing this back into the document and we write it back into the database. That's what happens. So maybe as a first step, I'm going to run this so that we can make sure that we have a clean starting slate. So Firebase emulator start. Oh, and there is one thing that I need to do, and I'm going to do this off screen because I need my key, my API key. Okay. Here we are. All right. So that's great. Looking much better than last time. So last time we had the issue that the emulator was really slow in booting up. I haven't figured out what the issue really was. Might have been a used port. So what I did was to make sure that we're using port 7777 instead of port 4000 for the UI, and that seems to have helped. Okay, so I'm gonna go and open my emulator window here, the UI, and we can go into the Firestore emulator here, and then maybe let's create a new document in our artifacts collection for texts. And I can just insert hello, for example. And then in the background, you notice that the function was triggered and it computed the embeddings for our full text and inserted them into the document. So if I change this to bonjour, it should trigger again, and we should get different embeddings. There you go. Okay, great. So, hey Lars, welcome to the stream. I've just given a recap for what we did last time. So, what we want to do now is I want to implement another function, or a flow rather, that allows us to ask a question, retrieve the documents, and get an answer. And we're going to do this step by step. So the first thing that we want to do is we want to define a flow. So let me put this here. So creating a flow. So last time we already built a flow. Quick recap. A flow in Genkit is like a JavaScript function, but it has a couple of additional features. The most important of those features is that you can inspect the input and the output and the general execution of this flow. And we're gonna do this a lot today. So let me try to put this somewhere where you can see it and I can see it as well. Okay. This is going to be very, very small. Okay. Okay, so let's start. Export const semantic QA flow is AI dot define flow. So we're defining a Genkit flow. This is really funny. Okay, so it needs to have a name, and the name can be semantic QA flow as well. And then we have an asynchronous function that we call, and this function will take our query, and then inside the function we can make a call to our model using AI.generate. And first we need to specify which model we want to use. So we've got access to Gemini 1.0 Pro, 1.5 Flash, 1.5 Pro, 2.0 Flash Experimental. So let's use 1.5 Flash for the moment. And then I'm going to specify a prompt. Tell me what I need to know about, and then we're going to access the query here. Query. Okay. My keyboard disconnected. That's funny. Okay, I don't know, but for some reason my keyboard seems to connect every now and then. So what we're going to do is I'm going to connect directly. Okay. Yeah, that's better. Okay, so the result of generate is an object, and that object has a text property, and we can use destructuring to get access to that text property. We should, at least. Oh yeah, so I forgot something. So firstly, we need to read that, but the other thing is generate is an asynchronous call, so we need to call it using await. Okay, so now the error is gone and we only have the warning, so now we can return the text. Great, okay. And now let's go back here. So this should still be running. But what we really want is, and I prepared this in my package.json. So we want to run Genkit and we want to run the Firebase emulator. So there is this slightly complicated command here. So basically what it does is it starts Genkit, and then at the same time it also starts the Firebase emulator and tells the emulator that we want to inspect the functions, and that helps Genkit to connect to the emulator. So I'm going to run this command, npm run emulator Genkit. Okay, so this should start the Genkit UI on port 4000, and then hopefully the emulator will also start. Maybe someone else is using the ports. If that's the case, I might need to kill Chrome. Okay. Okay, so we're still waiting for the emulators to boot up. Here we go. All right. Okay, cool. Oh, this is weird. Why don't we have a flow? Ah, I know. Okay. We also need to build this stuff. And I might have to save this one more time. Okay, here we go. All right, cool. So here's our flow. So we can go in, and now I've got this empty window here, and it expects me to send in some JSON. I have no idea how the JSON needs to look like, so probably let's construct an object, and then I named it query, and let's say TypeScript, and then run this. Okay, so here is the output. All right, so object is a string representation of a JavaScript object that you typically see when you try to log a JavaScript object to the console. So you can probably guess what happened, but let's take a look at what actually happened. And we can do that by looking into our trace. And I mentioned before that this is one of the specific features of Genkit flows that you can inspect them. And here we have our flow, our semantic QA flow, and you can see that it calls two other actions. And on the right-hand side here, you can see the input that we send to the semantic QA flow. And this looks quite fine because it is literally what I typed into the input field. But the output is exactly what we saw. So let's dig deeper and look at the generate call. So in the generate call, you can see that the input now is a lot more complex. And what happened is that when we made a call to ai.generate and passed in the prompt and injected the query that we got from the user, Genkit assembled this into a message that it then sent to the model that we're using, in this case, Gemini. So here you can see that we're sending the content, and here is our prompt. And here you can see that apparently we made a mistake when injecting this JSON object. So this is where our mistake is. So now let's try to figure out what the problem is. Let's go back into the editor. So I said query, and when I sent this in, and I can go back to the input here, I said .query, right? So I've got a JSON object, it's got a couple of attributes, and I specified I've got one attribute that's called query. So let's try this, query.query, and see if this works better. So the compiler should have compiled this in the background. Let's go back to flows. And you know what we can do is we can go back to our trace and inspect this trace, and then just open this again in the flow runner. So what it does, it just takes the input and puts it here so we can run this again. All right, so let's try this again. Let's see if I guessed correctly. So hopefully we'll now get an answer that is about TypeScript, and there you go. So TypeScript is a superset of JavaScript that adds optional static typing. Great, so our code works, but this is, not really type safe, and the IDE can't really help me. It's just making some random suggestions here. So what we can do is, if you look into the documentation for Genkit, you will see that we've got input and output schemas. So you can specify what data you want to send in and what kind of data you expect to get out of a flow like that. And Genkit will try to verify this. And part of that verification process uses a library called Zord, which is able to provide static runtime checking. And on the way back out, Genkit will also verify that the JSON that is coming back out of your model call, for example, matches what you specified in the output schema. So let's go back here and specify our input schema. And we need to import Z, which is the shorthand for Zord. And then I'm going to specify that I want to send in a string. And for the output schema, we want to return a string as well. So string like that. And immediately you can see that we got a compiler error here, which says property query does not exist on type string. And that is because here we said, well, this is a string. Pretty cool, huh? And this works for more complex objects as well. So you can specify nested structured objects using Zord. And for example, if you wanted to send in, I don't know, not just the user's query, but maybe you want to specify additional parameters as well. So you could send in an entire object. And on the way back out, that's pretty useful as well if you want to return the model's response and maybe how expensive that response was in terms of how many tokens you consumed and so on and so forth. Cool. So that's that. But we want to do more because we want to retrieve data from our database. So the first thing that we need to do is we need to connect to Firebase. And I've added the required imports up here. So we first need to initialize our application, then we need to get the Firestore instance, and then we need to create a retriever. And the retriever is a concept that is pretty popular in generative AI. It essentially is it's just a glorified fetch statement, really. So let's take a look at how you can build retrievers using Genkit. So let's go to retrieval augmented generation and then AI.define retriever probably. And here you can see that you can either define a custom retriever. So let's imagine you're storing your data in a database that is not supported directly by Genkit, right? There is no special retriever for it. Then you can define your own retriever and you can implement the data retrieval logic yourself. But the good thing is that there is a Firestore retriever which we can use. So let's look down here at Firebase and then search for retriever, and here we go. So we can just do this, and I'm just going to copy this entire block of code, and then we're going to go here, and I'll first import the retriever, and let's update the attributes here. Firestore artifacts, that is just a name. We're passing in the Firestore instance that we initialized up here. It's this one. And we need to specify the collection that we want to fetch from, artifacts, the field that contains the content, so that would be full text. And the vector field, that's the field that contains our vector embeddings. I think that was embeddings. And then we need to provide an embedder instance, and that needs to be the same that we used to compute the embeddings in the first place, so that it uses the same format and dimensionality. So we used text embedding gecko, like this, and there are a couple of options for how to compute the vector distance. Cosine is just fine, so we'll use that. And let's see what happens if I save this, because I'd really like to show you how to use that. Okay, so this is a compiler error. Let's see if this works. This works fine, but yeah, here we go. Okay, great. So I was worried that it might not keep this around. So here is our retriever, and you can see that it has the name that we specified. So we can input JSON. Okay, so it's got a couple of options here. So first we can provide the input as a JSON, and I was kind of hoping, yeah, sometimes you have to reload. So you can provide the text here in order to specify what you want to retrieve. And then down here you can specify the options, such as how many documents you want to retrieve. So before we can retrieve something, we actually need to put something into the database, because this has restarted. So that is one of the things you have to keep in mind. If you do it like I'm doing here, I'm running this compiler watch in the background, so whenever I change something in my code, the compiler recompiles the application. That means that the application restarts, and that command that I've been using, that also means that the emulator will start over and over again. So, and that means that the emulator forgets the data that you added. So it might be worthwhile using a different startup command. Anyways, this is just okay for us now. So we've got artifacts, full texts, and now what I'm going to do is I'm going to copy some text from somewhere. Let's go here and use some text from this blog post I wrote, which is about action menus in Swift UI. And then I'll paste this as the full text. And here are the embeddings. And then I'm going to go to Antoine's blog, and I'm going to get this blog post about enums. Hello? Oh, here it is. And I am going to copy this piece of text and insert it into another document. And then let's go and take this introduction text about Genkit and add this into another document. Okay. Cool. So we've got our 3 documents. Each document has a full text and embeddings for the full text. And you can see that those embeddings are different for each of the documents because the text is different. So now let's go and use our retriever and let's try to retrieve Genkit. Run this, and then we get the result. And here we see the first result. Genkit is a framework designed to help you build AI-powered applications and features. So let's compare this with the text here. Genkit is a framework designed to help you build AI-powered applications and features. So this is literally exactly the text that we put into the database. We can just verify this by reading the last sentence. It's designed to work with any generative AI model, API, or vector database. While we offer integrations for Firebase and Google Cloud, you can use Genkit independently of any Google services. While we offer integrations for Firebase and Google Cloud, you can use Genkit independently of any Google services. So exactly the document that we stored. But the interesting thing is, if we scroll down, you will see that we get other documents as well, right? They are just with a lower priority because they are less similar. And so this means this really only works really well if you either reduce the number of documents that you retrieve to a lower limit, or there is a lot more data in the database, which in our case will be the case, right? So in the end, we will have lots of documents in the database, and hopefully many of them will be about very different topics, but for each individual topic, we will have many documents, and that means the retriever will be able to retrieve the most similar documents. So let's give this another try, and I'm going to use for a search for Swift now. And that should give us Antoine's article, probably because it is about enums, and that is more of a Swift topic. And the article that I wrote about Swift UI, it is Swift as well, but it is more specific. So I'm kind of guessing that we should get Antoine's article first. So run this. Oh, that's interesting. So we get the Swift UI article first, and then the other one. So I don't know, maybe it might be that, well, we've got Swift a couple of times. Yeah, for some reason this is more similar apparently, which I find slightly surprising, but there you go. The third article is at the very end. So, and I think the default limit is 3. So maybe let's find another one. So let's find something about TypeScript. Okay. I'm looking for something that is slightly longer. Let's take, yeah, why not? Why not? Let's take this. Add document, full texts. Okay, we've got our embeddings, and let's run this again. Let's search for TypeScript. And run this And there we go, we get TypeScript first, then we get Genkit, probably because this uses TypeScript as its main language. And there we go, we've got Node, for example. And then we get the blog post about enums and Swift, and then Swift UI. So it seems, and let's limit this. Let's say we're going to limit this to 2. And so now we should only get 2 documents back. Awesome. Cool. So that's our retriever. And before I go any further, if you've got any questions, feel free to use the chat. It's always good to get some interaction going. I just talk into the void, so give me some feedback, folks. It's good to hear from you. All right. What's people's favorite model? What do you use for coding? What do you use for doing everyday jobs? I mean, like brainstorming ideas, or maybe even getting some help on writing your emails, or what you want to say on the phone, for example. So I've been playing around with Claude these past couple of weeks, which is really good fun, and it's so interesting. It's quite different from Gemini because it seems to have a very different personality, right? So it's more like yeah, I don't know, and you can even configure the personality, right? You can say, oh yeah, please be extremely concise and terse, or you could make it a little bit more chatty. So that is quite interesting. Carter says, I still just use ChatGPT, haven't explored much else. Yeah, that seems to be the most popular, right? So, and it seems to be the do you say moniker? Like it's the, if people talk about generative AI, they will say ChatGPT. And over the holidays, when I visited my family, of course we talked about work as well. And my sister has kids, and they go to school, and we talked about how they use AI. And whenever they talk about AI, they just say ChatGPT. So I suggested they might also have a look at Gemini. Let's see if they, next time I'll see them, they will say, well, I used Gemini and it was great. Or maybe they'll say, well, I still prefer ChatGPT. Oh, and then the other thing that I played around with is Alex Sidebar, and that is fantastic. So for the blog post that I showed you, the sample app that I used, because I knew exactly what I wanted. I wanted an application that shows a list of fruits and an action menu, and I wanted a couple of swipe actions on it. And with Alex Sidebar, you can talk to it essentially, right? So you press the hotkey, and then you can talk what you want. And I was able to build this entire sample app by just talking to the model and have it generate the sample app. And the quality of the transcript was perfect. It filtered out all my filler words, and the rest of the sentences was perfectly clear. And the code it generated was mostly really good and straightforward, and where it generated stuff that I didn't like, I was able to just select that and say, use this other API instead. And then it changed that and refactored the code instantly. So that was really amazing. And I think So because I knew what I wanted, I essentially used the model as a kind of like glorified keyboard, because talking to it was a lot faster than typing the code myself. So that was pretty cool. Yeah, so I found that Claude Sonnet does a pretty good job for Swift. So and that comes with Alex sidebar. You can switch to other models too, but Sonnet is the default model. I think they mentioned that they use it as the default model when you are in agent mode, which you need if you want to do stuff that goes beyond just a single file, which is the magic of Alex code. So Alex sidebar. What's the name? Alex sidebar. Yeah, Alex sidebar. That's it. Yeah, that is pretty cool. Oh, and then so that's something for one of the next times. So the one feature that has been missing in Sophia was a Chrome extension. So building a Chrome extension is not rocket science, but it's always been something that I dreaded doing, because I was like, oh yeah, lots of configuration files and putting code in all sorts of locations, and I always pushed it away. And then last week I used Cursor, which has a similar feature to Alex sidebar, to implement that, and it was the same experience. So I think it took me half an hour to implement a Chrome extension that stores the URL in Firestore and does authentication. So that is, it would have taken me a lot longer to implement this myself. So and I have no intention of becoming an expert Chrome extension developer. So it's a perfect tool for me. All right, let's get back to the job at hand, and what I want to do in the last couple of minutes is I want to enhance this semantic flow here, and instead of just sending this very plain and simple prompt here, we want to use the retriever to get the documents and then act on the documents. So the first thing that we need to do is we need to get the retriever, and I think yeah, let's start. So AI.retrieve, and then let's see which parameters we need. So we need the retriever, and that is up here. So const read. So here is a fun thing in TypeScript, Firestore retriever. So you can do it this way. So you can in the Firestore retriever down here. Like this. And then you need a couple of other parameters. Query is missing, so let's assign the query as well. Query. And you can see that with the query, I didn't have to do this. Right? I didn't have to pause the parameter. I don't know how this is called in TypeScript, but if the parameter has the same name as the variable, they get glued or like injected immediately. So if I rename my Firestore retriever to just retriever, then I can do the same here. That's actually pretty sweet. I like that. Okay, and then we can define some options. Yeah, sometimes it does not really work. So the limit, so we want to fetch 3 documents. Oh yeah, maybe it was because of that. Nope, limit 3. Okay, so we retrieve the documents, and that's probably an asynchronous call as well. Const docs equals await retrieve, and then when we make the call to generate, we can pass the documents. So we've got our prompt here. And now we can pass, oh, look at that. So we've got nice code completion here. We can provide the docs like this. And then we probably need to enhance our prompt. Tell me what I need to know about query taking the following context into consideration. Okay. Cool. The rest can stay the same. Let's go back. Oh, interesting. It did not restart the emulator. Did it compile? It seems like it did compile. Okay, so here's a retriever. Here's our flow. Let's ask about Swift. And here you go. Based on the provided Swift, here is what we can glean about Swift. And then it explains what's cool about Swift. Right? Let's try to ask about something that we didn't tell it about. How about Pascal? The provided text gives information about TypeScript, Genkit, and Swift enums, but contains no information about Pascal. Therefore, I cannot tell you anything about Pascal based on this context. So now I'm really curious what we got back. So let's inspect the trace. And you can see that this is a lot more complex than before. So we've got our semantic QA flow here. Let me make this a little bit larger. Okay, so our input was Pascal, and now let's look at the next level. So we are searching for Pascal. And so it got TypeScript back, it got Genkit back. So okay, let's look at this. So first of all, here is the call to the embedding model. So we take Pascal, we ask it to embed the text Pascal, we get those embeddings back. And then the retriever finds those documents. Let's see, what else is interesting? Yeah, so it retrieves those documents, and so let's see how many documents we got back. So we said we want 3 back. So 1, 2, 3. So we got 3 documents back. And all of them, so this one talks about TypeScript, this one talks about Genkit, this one talks about Swift. And then we pass all of these into the generate call. So we provide them as a context. So here's the docs. Here's our prompt. And here's the response. And let's look at what Genkit passes to the model. So it provides the prompt, and then it injects the documents. And this is really interesting, right? So let's look at this. So here is the text that we fetched from the database. So this is the first document. And this part here, use the following information to complete your task. That is something that Genkit injected for us. And then we've got it seems like this is an enumeration. So dash and then bracket 1, bracket 0. Here's bracket 1, bracket 2, and that's it, right? So we can look at this in a larger window. So it provides this nicely formatted input to the model. So, and with that, we can now play around with it, right? So we could say, well, you know, it seems like using 3 documents is not such a great idea. I'd rather use, you know, a different number of documents. So we can go in and say, well, you know, open this in the retriever runner. We've got our limit here. Let's just use 1 document and then see what happens. So we get just 1 document back. And we can then take that and play around with it in our code editor. And we can say, okay, let's just use 1 document here. Go back and run our flow. Bye, Carter. Thanks for joining. And then run this again. So let's ask about Pascal again. So now it says that the text describes TypeScript, not Pascal, right? So maybe what we can do is, so the retriever will always return, you know, at least a document. And oh yeah, let's try to say that the limit is 0. I wonder what happens now if we get no documents back. Let's take Swift, because that is something that is in the database. Okay. This looks promising. So it still gives an answer. So limit 0, output, and we get, oh yeah, so interesting. That's really interesting. It gives us everything back. I wonder if this is intentional or a bug. So if we had more time, I would probably dig into the source code to figure this out. But we're already at the 1 hour mark, and I don't want to keep you long now. So let's look at the code one final time. So what we did today was we implemented this semantic QA flow, which uses a retriever to find the most similar documents that match the user's query, then injects them into a prompt and asks the model to generate an answer based on those documents. And that is what allows us to you know, have a conversation with our knowledge base. And the next time, let's see. So obviously we want to get to a point where we can actually have like a chat conversation. So maybe that's something that we can look into next time. I also want to, you know, I also want to show how to implement a chat component. That might be a Swift UI topic, but we could use a pre-made component and then just focus on how to interact from a Swift UI application or a Swift application to a Genkit backend. So what we definitely need to talk about next time is, 1, how to expose a flow like this one here so that we can call it from a mobile application. And if you know anything about Firebase, which we're currently using to run this, then you might know that we will probably use Firebase Cloud Functions to do that. So that is one thing. And then the other thing is, so this here is a super simple prompt, and we would probably want to make this a lot more elaborate, which means that the prompt will probably be quite a few lines of text, and it will probably be rather cumbersome to have that text be part of this the source code. So I want to look into using this part of Genkit. It's called .prompt, and it allows us to extract our prompt into an external file, into a .prompt file. And this is really, really powerful, and it allows you to decouple your team members, right? So the people who work on the backend implementation can continue working on the backend implementation, and the people who want to optimize the prompt can just do that in this text file, and they won't step on each other's toes by working in the same file like here. Great. So thanks for joining, everyone. And hopefully the sound quality was a lot better today, which, looking at my microphone gauge, it looks like. And also, I'm really happy that the emulator booted up faster this time. So that was a much better experience than last time. All right, so there is another message on the chat. Would it be possible to dedicate one podcast on commenting about on commenting lab that you prepared with other members of the team? All right, tell me more. Dean, can you say which lab you meant? Was it the one that I ran together with Noe? Yeah, we'll figure it out. So probably next week, probably Tuesday, probably the same time. Build Gen AI features powered by your data with Firebase Genkit. Yeah, we can look into that next time, for sure. All right, folks, thanks for joining. It was great fun. Enjoy the rest of your day wherever you are on the planet. Stay safe, and I'll see you next week. Bye.